This is Julia Miller from the EPA State Climate Energy Program, and I want to thank everyone for joining us for today's technical forum webinar on deciding what approach to use when quantifying the emission impacts of energy efficiency and renewable energy programs and initiatives. We did several webinars last year on related, more specific topics, including EPA's eGrid tool, how energy efficiency and renewable energy can benefit the electric system, and quantifying job impacts of EERE. We received feedback from many of you that you wanted more general information on the range of approaches that you could take to quantify emission reductions from EERE, and so we're hoping to provide that for you today. So we have Robin DeYoung from EPA. She's going to give a broad overview of approaches, and then we'll have Sharon Weber from Massachusetts and Carol Semrich from Wisconsin, along with David Sweeney of the Cabinet Group, talk about their experiences at the state level. And I'd like to take this opportunity to thank them for taking the time to be with us today. Listed at the bottom of your agenda is a web link that you can use to find all the presentations for today's webinar, as well as other background materials. And also a recording and transcript of this webinar will be posted at that site in the next week or two. We're going to do our next Tech Forum webinar sometime in late February on EPA's greenhouse gas data reporting tool. So we haven't set a date for it yet, but we should have that information out to everyone in the next week. We're also planning to do a webinar in March on some of the new work we've done at EPA to help states account for energy efficiency and renewable energy programs in their state implementation plans. As always, if you have any topics that you'd like to suggest for future webinars related to energy, air quality, and climate change, you can email me at miller.julia@epa.gov. So now I'm going to hand the webinar over to our facilitator, Catherine Morris from the Keystone Center, and she'll cover some of the logistics and get us started.
Thanks, Julia. This is Catherine Morris, and welcome everybody. We do have a very large audience today. Over 200 people are already on the webinar. Some of you may have noticed that there was a little bit of delay in getting into the audio, and I think we probably have some other people still entering. So we waited a little bit so everybody could get on. You are muted, as you obviously found out, and what we've done is provide, what we'd like to do is encourage your interaction with our speakers by asking them questions through the Q&A on the GoToWebinar screen. So you have a control bar which you can deminimize if you'd like during the presentations, but open it up so that you can type your questions into the question bar. They'll come to the host and the presenters, and we will be verbally asking as many questions as we can get to. We have some time after each speaker to ask some clarifying questions. We'll take about 5 minutes after each of them have finished their presentation, and then we try to reserve as much time as possible at the end for additional questions that we weren't able to get to. So with that, I would like to introduce our first speaker, Robin DeYoung. She has been working at the US EPA since 2010. For that, she was working at Ohio EPA Air Pollution Division, and there she was responsible for managing the statewide emissions reduction trade credit and banking program under the new source review program, and she also developed Ohio's state greenhouse gas inventory. And importantly, she was sort of the liaison between the Air Pollution Division and the Ohio Department of Development, and also the Public Utility Commission staff. So, Robin, we'll hand it over to you and open up your slides.
Great, thank you, Catherine. So today I am going to talk about how you can decide which approach to use when quantifying the emission impacts of clean energy policies and programs. And on the next slide, it gives an overview of the presentation. First, I'll talk about some important terms that I'll be using throughout the presentation. Discuss which electric generating units you would generally be displaced when you implement clean energy policies and programs. Then I'll transition into the decision-making process, where we'll talk about some important factors to consider when you're deciding which emissions quantification approach to use. And then I'll give you a little bit more detail on 4 different approaches. And I should mention that these 4 approaches are a sample representation of all of the different quantification approaches that are out there, and they also they represent basic to sophisticated approaches, so you can get a sense of the scope. On the next slide are some common terms and abbreviations. First is clean energy, and clean energy is a zero or low emitting option to meet energy demand. So what I'm talking about here is energy efficiency, combined heat and power, and renewable energy. An electric generating unit, or EGU, you'll see that abbreviation throughout, is a power plant or a generator that produces electricity and is connected to the grid. A baseload EGU is one that operates near maximum capacity most hours of the day. So examples of that would be a nuclear power plant. In most cases, coal or hydro plants are baseload EGUs. Depending on the region, they could also be a non-baseload EGU, which brings us to the next definition. And a non-baseload EGU is one that fluctuates their generation based on changes in demand. And then the next set of EGUs are peaking EGUs. And these EGUs only operate during the highest demand periods. So for example, if you're experiencing a high electric demand day, it's a hot day, everyone's putting on their air conditioning, these peaking EGUs are the ones that will come on to meet that additional demand that you would normally see on the system. And then finally, this marginal unit concept. A marginal unit is the last or next EGU that comes online to meet demand. So a non-baseload EGU or a peaking EGU could be that marginal unit if it is that next EGU that needs to come online to meet demand. So those are some basic concepts. And the next slide is where I'll talk about when and how clean energy policies reduce emissions. Here to explain this concept. On the right-hand side is a typical daily demand profile. And the baseload EGUs are the ones that are below this horizontal dotted line. So just imagine you wake up on a Monday morning, you turn on your appliances, your lights, you go to work, you're turning on your computers, and as the day keeps going, we are increasing our demand. So as the demand starts to increase, these non-baseload EGUs are the ones that come online to meet this additional demand. And so the opportunity to reduce emissions is in the space above that horizontal dotted line on that right-hand side. And this is where the opportunity is. Another example on the left-hand side is a hypothetical EGU dispatch curve. So what you have is a full week, and the plants that are operating the whole entire week consistently are your nuclear and new coal plants in this hypothetical example. And if you go, if you climb up that dispatch curve all the way to the top left-hand side, you can see that these are the most expensive units, and they are the ones that are dispatched last. And so if you're adopting, let's say, an energy efficiency program, the opportunity to reduce emissions are at these EGUs that are the most expensive and dispatched last. And the next slide, I've given a couple of examples of some common energy efficiency or renewable energy policies. And you can see them listed here. The way you estimate the energy impact of these policies is you use a metric megawatt hours. And so if you want to estimate the amount of electricity that you're consuming or the amount of electricity that you're saving, you would use the megawatt hours metric. And an important point that we like to make is that capturing the energy impacts of the clean energy policies at this higher level will provide the most emission benefits. So, for example, a lot of times we see people are measuring the emission impacts of the small little measures, or at the program level. And if you start top down, you will actually see that the most emission benefits if you use that strategy. And the next slide is when we start getting into the emission quantification approaches. So let's talk about that. I've categorized the two approaches. I've categorized the approaches in two different ways. One is a basic approach or a sophisticated approach. And a basic approach can meet your needs if time or resources are limited, or you need let's say you need a preliminary analysis. A sophisticated approach might be the way to go if you have policy options that are very well defined, you need a high degree of precision or analytical rigor, and you have enough time, data, and financial resources. So on the next slide, gives you a little bit more detail, and what I've done is I've created a matrix to help you choose which method is best for you.
Thank you.
And on the left-hand side of the matrix are the key considerations you should think about when selecting an approach. From on the top, left to right, are the different approaches. And so the first two approaches here would be considered the basic approaches. The second two approaches, or the last two approaches, would be the sophisticated approaches. And so what you can do is you can ask yourself several questions that will help you narrow down your options. So, for example, what is the purpose of your analysis? What types of emissions are you interested in? What geographical and temporal scale is needed? Or how much time and resources do you have? And so, depending upon how you answer these questions, you can find one of the approaches that could meet your needs. So we also have, we want to hear from you, and so what we want to do is now launch a poll question for you to answer to make this a little bit more interactive. So we will launch this poll to find out, what objectives do you want to accomplish with your energy efficiency or renewable energy emission quantification efforts? So we'll give you about 30 seconds to make your choice, because we want to find out, what are you guys most looking for right now? Are you conducting a preliminary analysis? Are you estimating voluntary program results? Maybe you're providing general benefit information to the public, or you're more likely to meet regulatory and statutory requirements for these emission quantification approaches. Great. So let's see what you guys have to say. Okay. So it looks like most of you are looking to provide general benefit information and estimate voluntary program results. Okay, great. And then the runner-up is the regulatory and statutory requirements. Excellent. Well, thank you for your vote. Moving on. So the next slide, basically use that last slide as a cheat sheet for helping meeting your needs. The next slide talks about some of the available data sources. And the reason why I have this here is because, if you can go back to the available data sources for a second. This is going to be an iterative process. You're looking at your approaches, and you also want to find out the data sources that are underlying each approach. So here we have EPA's eGrid database. We have EPA's Clean Air Markets Division database. And Wisconsin uses this data source to help them with their emissions quantification approach. So you'll hear more about that later on this afternoon. Or if EPA's emissions and generation information isn't what you need, you can turn to your state emissions inventories. For example, Massachusetts, you'll hear from Sharon from Massachusetts, where they actually changed their data collection system so that they can meet their emissions quantification approach needs. On the next slide are the full list of the four quantification approaches that I'll discuss. And before we jump into the more detailed information, I just want everyone to know that the next couple of slides have a lot of information on them. I'm only going to touch on a couple things, the advantages and disadvantages, so that we can just focus on how to choose your approach. But please use this as a resource. There's plenty of links and things like that for you to check out more information, and you can always give me a call if you have questions. So next slide, please. Good. Subregion non-baseload emissions rate approach. The advantages of this approach is it requires very low resources. We already have calculations set up that you can apply. It's great for annual emission reductions, regional and national estimates. One of the limitations of this approach, though, is the most recent year of data, 2007. So if your EGU fleet has turned over in the last 4 or 5 years, then this approach might not be the best. However, we are updating our eGrid numbers, and they should be coming out hopefully very soon. Next 2 slides. We have informational resources. And then we have the EGU capacity factor approach, another basic approach. And if you could move to the next slide here for the EGU capacity factor approach, we can talk about some of the advantages and limitations. One advantage to this approach is that you can get the emissions at the EGU or plant level. So this would be great if you want to know exactly, what area, what county, what small geographical area could I see emission reduction potential. One of the limitations of this approach is that the capacity factors are approximate, and they don't always account for maintenance and outages, etc. So this is something that is useful, but it is heavily caveated. Okay, next approach, please, or next slide. The hourly emissions rate approach. This approach you'll hear a little bit more about from our Wisconsin speaker today. And it's one of the great things about this approach is that you can look at the emission reductions during high electric demand days. And then if you could go to the next slide. So you can get continuously quarterly reported data from EPA at the emission unit level, so you get very refined data. One of the limitations, though, now that we're getting up into the sophisticated approaches, is that this can be data intensive if you don't have the infrastructure set up. And you do need hourly load impacts of energy programs to make this work. Next slide, please. And then finally, we have this energy modeling approach, which is the most sophisticated approach. This is very useful for regulatory analysis. And you can see here it uses very many different parameters and user-defined constraints. And it also can look at the interaction of the electric grid. If you could go to the next slide, please. Here are some examples of this approach where you can find out more information. And then one more slide. And then here are some of the advantages and disadvantages of energy modeling. One of the advantages is that if your EGUs are required to comply with the cap and trade program for a certain pollutant, the models are able to adjust their behavior based on these environmental constraints. But one of the disadvantages is that it does require high-intense data. These models are proprietary, so you would need to have a contractor help you or a consultant help you use these, or you might have to buy some software licenses, things like that. And then the last slide is really my contact information. If you have questions, feel free to contact me. But I mean, in conclusion, this is really to give you just a brief understanding of what are the things you think about when you're looking to quantify emissions, what approaches are out there, Remember, it's an iterative process depending on the data availability and your analysis needs. And our speakers from Massachusetts and Wisconsin will be able to give you some examples that they've done in the recent past that will help you for your emissions quantification analysis.
A couple of, I should have said this at the beginning when I was giving you some of the background. We have posted on your welcome message on the right the website where you can get Robin's presentation, the other presentations, and as well as background information for this webinar. It's www.epatechforum.org. You should see it on your screen. I've gotten a couple of questions about that. So please feel free to download those either during the webinar or afterwards. Robin, a couple questions came in during your presentation. One while you were talking about the marginal unit approach, and the question was, are there circumstances when an energy efficiency program or measures might actually go beyond the marginal unit and affect base units or base load? And if so,
thank you, Catherine. Yes, there are instances where, let's say you're looking at a certain renewable energy technology. That might be an example where they could affect baseload emissions. And so what you would want to do is you would want to be able to understand how the policy reduces emissions. Maybe it reduces emissions during nighttime hours, and that's one of the reasons why it's affecting baseload. So you want to pick the appropriate emission factor that represents the EGUs that are reducing emissions. And so that's really a good point there. You do want to have a detailed enough understanding of your energy efficiency program so that you do pick the correct emission factor for your analysis.
The question was regarding the matrix you had on slide 7. I don't know that we need to go back, but if it's easy to do that. On slide 7, you were showing the various approaches, and one of the questions was how would you also rank those approaches in terms of the dollars, cost, and resources needed to actually implement them?
Well, I do have on the bottom part of the matrix where we have time, money, and maybe the one part got cut off. It was time, money, and staff expertise. And so I would rank from least expensive to most expensive left to right. So, either sub-region non-baseload approach would be the lowest amount of money needed because we already have the resources all ready to go, all the way up to energy modeling where it would be the most expensive.
Thanks. Let me see if I can get one more question in. There's a couple of questions that will probably take a little bit more discussion. We'll hold those till the end. Another question about slides 14 and 15. Are there price versus time data that would support the use of solar and wind distributed generation with, I'm afraid I've lost the end of this, with respect to time?
Sorry, can you repeat that?
Sure. Under slides 14 and 15, are there price versus time data that would support the use of solar and wind distributed generation with respect to time? Does that make sense? If not, we can ask for whoever submitted that question, if you could, Dorothy Allen, if you could just provide maybe some clarification, we can get back to you.
Yeah, that would be helpful. Thank you.
Okay. All right. Well, let me go ahead and introduce our next speaker, Sharon Webb. Sharon, I know you were pressed for time in joining us, and thank you very much. Sharon's been working at the Massachusetts Department of Environmental Protection since 1997, and in that time she has worked on quantifying the aspects of energy emissions since the adoption of the NOx emissions trading program back at the end of the 1990s. She has an MS in Environmental Engineering and Policy from Tufts University and a BS in Material Science and Engineering from MIT. And I believe you're going to handle the slides yourself, Sharon, so we'll hand controls over to you for that.
Okay, do you see my slides yet?
We do. Thank you.
All right.
Get going.
Thanks so much. So I want to cover three items today. One, I want to talk about a way in which Massachusetts has actually estimated the emissions benefits of some clean energy impacts programs. And then I'm going to talk a bit about the NEEP Regional Evaluation Measurement and Verification Forum. And then very briefly, I'm going to mention a DOE project that's ongoing in the same efforts. In Massachusetts, we have a large effort underway. In 2008, our legislature passed a law that indicated that we were interested in placing a lot of effort in energy efficiency. And the result of that have been energy efficiency plans that each of the utilities in the state have to develop. Each of them go over the course of a 3-year time period. We are spending $2 billion in 2010 to 2012 time period to get benefits that we estimate will be worth $6 billion in avoided costs. So this is a big commitment by us. We think it's going to have big impacts for ratepayers, saving them money over the long haul. And as part of that, people have asked, well, what kind of emission benefits have you seen from such a program? It's a natural question. And we, last summer, have published our first report for the 2010 calendar year efforts at the link on your screen if you want to read up on it. The initial report estimated reductions for 3 groups of pollutants, greenhouse gases, nitrogen oxides, and sulfur dioxide. And the simplistic way we did this, really, was multiplying an emission factor by the megawatt hours of electricity that were saved by the energy efficiency plans. And then for natural gas, we multiplied an emission factor by therms, and for oil we did it in terms of MMBTUs, millions of BTUs of heat input, which is a measure of how much energy is in the fuel that is burned. So getting to the point of being able to have an emission factor to multiply, though, took a lot of work, and actually is the result of years of efforts. For NOx and SO2, Massachusetts has been working with our ISO New England, on a report that they put out every year that estimates the emissions associated with the power plants that are putting electricity on the grid. And I have the link there for the most recent emission rate report that they put together. So for those pollutants, we used those regional emission factors for NOx and for SO2. For greenhouse gases, we were in a different place. The legislature in Massachusetts requires people who sell electricity, retail sellers of electricity, to report their emissions to the Mass DEP. And they require that in doing that, we consider the power that gets imported into Massachusetts. Massachusetts imports a quarter of the power we use. So when I looked around for sources of emission rate data to use, you're not going to find much out there that has to do with rates that account for the reality that some states are importing power and some states are exporting power. So we had to develop that ourselves. And we have done that now for 3 years, 2006, 7, and 8, in a spreadsheet type approach, which is posted on our website. We've used 3-year averages in estimating the greenhouse gas benefits for our first year of our 3-year energy plan, energy efficiency plans. And the reason we use a 3-year average is that we don't yet have 2010 emission data that we might want to marry to 2010 energy savings in an ideal world. So since we don't have them, I hate to just grab a single other year to try to use an emission factor. It tends to distort things depending on the conditions of some particular year that you had certain power plants online or offline. So I generally like to use at least some average of a few years, and 3 years is sort of the default. So we used a 3-year average so that we wouldn't be just focusing on a single other past year that wasn't representative, perhaps, of 2010. So these emission factors, the fact that they're a 3-year average, you have to think about why we were doing this. We were just trying to make an estimate of emissions, and the energy that's saved, that is the megawatt hours and the therms and the millions of BTUs, those numbers weren't even final when we did the emissions estimates. So this wasn't an exercise in trying to get a precise inventory or to get SIP credit for this, at least not to start with. Someday maybe we'll go there. But for right now, an estimate is what we needed. And you'll note on this slide that a couple places I use the word average emissions, not marginal. Robin did a nice discussion about the differences between average emission rates and marginal emission rates. And I guess from our perspective in Massachusetts, if marginal emission rates that were valid were available, we might be interested in using them. But we haven't been able to find a source yet that's sort of publicly available. And I have been working with our ISO in New England to see about doing some different kinds of marginal emission rate calculations and analysis to find out what the rates might be. So, in the future, we might move to using marginal rates, but we're started out using average. All right, so I mentioned these greenhouse gas emission rates, and the lingo we use to sort of communicate the fact that we're using rates that account for imported power is that they're based on consumption as opposed to generation. So it's the consumption of electricity in Massachusetts, not the generation solely in Massachusetts. We initially did this, as I said, the legislature had reporters, required reporters of retail sellers of electricity to report their greenhouse gas emissions to us, and they also required the Mass DEP to establish emissions inventory. So if you want more background, there's much to read at the couple links I've got listed there on the slide. We didn't want to look solely at our in-state generation because it would have underestimated the emissions associated with the electricity we used. And because the legislature required this as a part of a process under something we call the Global Warming Solutions Act here in Massachusetts, we had a lot of public meetings and feedback from the public on how we might think about these kind of emissions. So we actually post our greenhouse gas emission factors each year for public comment. And then the folks that have to actually do the reporting to us, they're always your best source of feedback, frankly, because they have to deal with the realities of submitting information back to us. And so they also have offered us very good comments and feedback. The one exception to what I said earlier that folks use the average emission rate, we do allow our retail sellers of electricity to take credit for power they use that is non-emitting. Or, for example, some of them have contracts for solar power or for hydropower or for wind power, and they have a lot of interest in being able to get credit for that. So we have set up a way for them to each individually take credit if they wish for the clean power that they use, which is a way that we hope encourages folks to do more of that, because if you can get credited for your good actions, then perhaps you'll do more of that. Challenges. Folks wanted to hear how this has worked for us or been difficult for us, as the case may be. The big problem on this is probably timeliness. I think Robin alluded to the fact that eGrid, most recent year available is 2007 data. But in our calculations for our emission factors, we've gone back to some of the reporting that's done to the Federal Department of Energy and to the Environmental Protection Agency. And the data that is available because Massachusetts imports power from, or at least the New England area imports power from Canada. We've also had to think about data availability from Canada. So it's quite a few different data sources, and it takes quite a while for them to all be issued so that we can calculate our emission factors. We're environmental people, but we've ended up having to learn energy lingo, which has been fascinating but time-consuming. You just have to get used to new terms and acronyms that you haven't used in the past. Similarly, because some of our power is coming from Canada, we've had to learn some of the lingo for other countries, specifically Canada, on the environmental side. Department of Energy databases we've had to get familiar with. We had to figure out how to allow credit for clean power purchases, but while trying to remain true to the system, that is, not allow double counting. You don't want to allow some folks to count clean power and at the same time allow other folks credit for it. We have an existing renewable energy credit tracking system in New England, so we do that tracking through a system that allows us to ensure that we're not allowing double counting. And lastly, the regulation, we thought we were being kind of broad in what we wrote in the regulation and purposely put some of the detailed methodologies out for public comment separately each year so we wouldn't have to go back into the regulation itself and revise it. But even trying to do that, we found that some things that are in the regulation itself have needed to be revised over time. So a lot of learning. I want to speak briefly about the Northeast Energy Efficiency Partnership. This is a regional group here in the Northeast, and they have been getting funding from public utility commissions and energy offices to work on an evaluation, measurement, and verification forum, supporting the development of consistent protocols to evaluate energy efficiency. And some of the objectives for being involved with this is overall, we think we'll get reduced emissions if we use more energy efficiency. This is really high level, and that leads to improved air quality for the residents in the state. So that's probably the biggest picture reason why we would want to be pushing energy efficiency. But we also have a big interest in ensuring that air quality is considered as part of the evaluation and measurement process. Folks for years have been trying to get the measurements correct as far as quantifying the megawatt hours that you've saved or the therms that you've saved or the millions of BTUs that you've saved. But now we're trying to marry that to the air quality data. See if we could get it regionally or nationally, if that's ever possible. We want to make sure that air quality benefits are documented so that people realize that energy efficiency has multiple benefits, and it's even more reasons for why energy efficiency should be part of people's thinking. One of the questions that Julia had us focus on for these presentations was how we decided on the methodology that we used. And the EM&V forum hasn't come down on a final methodology for quantifying emissions, but things that we've considered are things like this question of marginal rates versus average rates. Where can you get that kind of data and get it in a replicable, reputable, accurate level of detail. As doing this EM&V forum work, because it's in New England, there's already a group of air regulatory agencies that meet under the guise of NISCOM, which is the Northeast States for Coordinated Air Use Management here in the Northeast. So, you know, different states have different perspectives, so it's always helpful to go back and talk to your colleagues about different approaches. Challenges, terminology. Oh, just trying to keep straight the energy lingo for this environmental folks, and then vice versa. I often find myself having to have folks define acronyms for me. How this has been evolving, you know, you really do need the measurement and verification methodologies first to be able to get the megawatt hours and the therms and the millions of BTUs quantified accurately before being able to marry those kind of energy numbers to emissions factors. To a certain extent, if your energy reduction values aren't accurate enough, it doesn't really matter how you're going to marry them to emission factors. So the evolution here has been somewhat a matter of waiting for the energy efficiency reduction value methodologies to be robust enough to then bother to justify hooking them up with with emissions factors. And then just one quick plug or slide on a project that the Department of Energy is in the midst of right now. Department of Energy is working with National Renewable Energy Laboratory trying to set up protocols for measuring and verifying the savings from various energy efficiency programs, different sectors, as I've listed here on the slide. And we couldn't support this work more. It is really, as I said on the previous slide, it's fundamental. If you've got to have the energy efficiency numbers right in order to then justify marrying the emissions factors to those energy reductions and coming up with estimates overall of your energy benefits, of your emissions benefits. I think there. Yes, I've got through most of what I wanted to touch on.
Great. I know your last slide has your contact information as well, which might be helpful for people who want to follow up. We got a lot of questions while you were talking, Sharon. One of them, just going back to your one of your earlier comments about how you made the decision to rely on average rather than marginal emission rates. Mm-hmm. And so one of the questions was, will that result in fact, lower emissions values for the energy efficiency, since average tends to be lower than marginal emissions?
It could. It's kind of funny here in New England, although this may be happening in other parts of the country now. Our average and our marginal rates are getting closer and closer together because we use so much natural gas. If you consider the natural gas unit to be the marginal unit, our average emission rate is starting to get close to that of a natural gas unit. So, but you're right. Yes, there could be some underestimation by choosing to use average values.
And this might be a question that Robin might want to follow up on later, but one of the audience members noted that there seems like there's one potential downfall or pitfall in all of these approaches, being that because, as you mentioned, the electricity system is very interconnected, all of your emissions may not be in-state, in fact may be regional, and a lot of imported. And so the question was, you may, in fact, if you're using a more, the geographic location of where the efficiency measures are actually implemented, you may be getting a false reading on what the emission benefits are. And do you have any advice about sort of avoiding that type of pitfall?
It sounds like a question about the accurate measurement of the energy side of the house, the energy reductions. I know in New England we do a review every 2 years of sort of on-the-ground costs and benefits from energy efficiency programs. Actually, they even more frequently than that, I should say. There's quality assurance done on the estimates for energy efficiency programs. So those sort of analyses and quality assurance activities in Massachusetts' case are specific to our 3-year energy efficiency plans. So I would argue that they are very localized to our state, but I don't know the situation across the country.
Yeah, and this is Robin. Oh, did you want me to answer that now or later?
No, go ahead, Robin.
I guess what I would say is that the person who asked the question has a really good point, that you do need to consider the geographical scale of your analysis. So the electricity does go across state boundaries, and a lot of times what you need to do is you need to look at either the NERC regions, the sub-NERC regions, looking at imports and exports, such as Massachusetts did, to get the right geographical boundaries for your analysis. That should be flexible, and you should do a little bit of investigation on what that boundary should be. When you're looking at eGrid, eGrid has their own boundaries, and there is imports and exports factored into the boundaries that are listed there. The other thing to think about is even if the emissions aren't happening in your area, if you're looking at criteria air pollutants, if you're downwind from an area that you see benefits emission reductions, then that downwind area could still reap some benefits from the emissions being reduced upwind. So that's another thing to consider.
Helpful elaboration. There were a number of questions, Sharon, also about a comment you made under challenges that you face with your approach. One, you talked specifically about allowing credit for clean power purchases and trying to prevent double counting. Could you just elaborate on that a little bit more about how you did prevent, what measures or what steps you need to take to prevent double counting?
So in New England, we have an existing tracking system called the GIS, which is not the same GIS that people typically use that acronym for, Generation Information System in this case. And parties, each power plant that generates a megawatt hour of electricity gets something called a certificate, and then somebody may purchase that certificate, so you can tell at the end of the day what account that certificate lands in. So when our retail sellers of electricity report to us, they can tell us, I actually did get that particular megawatt hour of power from that particular clean power plant, and nobody else got it. And I can prove that because there's this tracking system, and only one person can end up with a certificate in their account. So we have the luxury of having a good tracking system already here.
Thanks. One more, let me just slip this question in because it goes back to some comments Robin made about eGrid. One, does eGrid allow you, because when it looks at the NERC region level, to take into account imported power in your region?
I mean, this is Sharon, but I'm sure Robin might have an answer here too. eGrid did look at imports many years ago when it was first created, but in recent years I haven't seen it attempt to account for imports and exports between particular states. Robin, is that your understanding?
Well, that's right. Well, I guess I would caveat that where the eGrid regions go across state boundaries. So within that eGrid region, if it is able to capture the generation from multiple states. The imports and exports across eGrid regions, which could be larger than a state, is not currently accounted for, but you are able to get an average of either a non-baseload average or for a particular region.
Thanks, Robin. There are quite a few other questions, but I'd like to move on to our next presenters. And we have kind of a tag team here. I'm going to introduce them both. And our first speaker from Wisconsin is Carol Stemrich, and she's the Assistant Administrator of the Gas and Electric Division in the Wisconsin Public Service Commission. She's brought her engineering experience to bear for the last 25 years on the energy efficiency field, and more specifically in Wisconsin, she has been working on the oversight of the Focus on Energy program and all of other Wisconsin statewide energy efficiency and renewable resource programs. She's joined today by Dr. David Sumi, who is the Executive Director of the Cadmus Group. They've been working closely together on the Wisconsin Focus on Energy program, and David, in fact, has some history that he's able to share with us about how the program got started and what some of the original rationales were for selecting the approach they use in Wisconsin. Just as background, he has over 25 years of experience in evaluation performance measurement research, and his work has looked at energy efficiency, demand-side management, as well as quantifying not only the displaced power plant emissions from these types of programs, but also the statewide economic impact benefits and other non-energy benefits. So I'm going to turn it over to you, Carol, and we'll get your slides up and running for you, or you're going to do that yourself, and then we'll move into your presentation.
My slide is not up?
No. I'm not seeing it.
You can see it here.
I do.
Yeah.
Okay, I may have lost the connection. Go ahead.
All right. Again, my name is Carol Stemrich, and I work for the Public Service Commission of Wisconsin. Like Massachusetts, Wisconsin has a long history with energy efficiency, and I'm going to start out with a little bit of background on energy efficiency, mainly because where we've been and where we've gone definitely influences how emissions are currently addressed. Until about 2000, Wisconsin investor-owned utilities delivered energy efficiency programs in the state. They were required to deliver cost-effective energy efficiency and renewable resource programs as a result of our advanced plan, which was Wisconsin's integrated resource planning process. Quite well until the mid-1990s when Wisconsin began discussing restructuring in the state. As you can imagine, some of the utilities began to propose fewer, lesser goals for energy efficiency at the time in anticipation of a restructured industry. We had one utility in particular who wanted to greatly reduce their goals. As a result of that, and because we wanted to sort of have a test of a third party delivering energy efficiency in Wisconsin, we implemented what was called the Focus on Energy pilot. This occurred in, I believe, 1997 through 1999 in that time frame. After the pilot ended, 1999 Wisconsin Act 9 came into effect. That resulted in full third-party delivery of energy efficiency programs in Wisconsin. So the utilities were no longer directly responsible for delivering those energy efficiency and renewable resource programs. Under Act 9, our Department of Administration had oversight of those statewide programs. In 2005, Wisconsin Act 141 made some changes to the statewide energy efficiency and renewable programs. The one thing they did was change the funding source, and this was basically because some of the funds under the previous structure were diverted to help balance the budget. They also increased funding for energy efficiency and renewable resource programs, and oversight of the programs transferred from the Department of Administration over to the Public Service Commission. Now, the value of energy efficiency has long been recognized in the state of Wisconsin. Under our advanced plan process, the utilities were required to monetize greenhouse gases. And those monetized dollars were used to compare the demand-side resources, the energy efficiency and renewable energy resources, to supply-side resources. 9, environmental protection still was an important objective of those statewide energy efficiency programs, and that continued under Act 141, which stated that its purpose the purpose of the programs should be to achieve environmentally sound and adequate energy supplies at reasonable cost. So leads us to why we determine emission benefits from energy efficiency and renewable resource programs. Again, as you saw, one of the major objectives of our statewide energy efficiency programs is environmental protection. So one of the objectives is to document that the statute is met. However, equally important is to appropriately reflect the environmental benefits in the evaluation of energy efficiency and renewable resource programs. Reflecting those environmental benefits is one tangible way for emissions effects to be appropriately credited to the programs. How we do this is we use a total resource cost test, which began under the oversight of our Department of Administration. This was continued as the programs transferred to the Public Service Commission. And also under Act 141, the Commission was required to go through a 4-year energy efficiency and renewable resource planning process called the Quadrennial Plan. And the Commission's decision in this planning process confirmed the use of the total resource cost test. So how did we actually develop the method that we use to value those emissions? Under the Focus pilot, which again began in the late 90s, the Department of Administration actually requested the Lawrence Berkeley National Lab to develop a method for the Focus pilot. Unfortunately, I don't have much information on this because anyone who was around at that time is no longer around, and it wasn't documented very well. However, we do know that there were several enhancements made to that method under Act 9. Those enhancements include development of multiple load duration curves, identification of the marginal generators during different times of the year, and these include peak and off-peak for each season. We also began using additional plant-specific data for heat rates and emissions, and began using a subset of power plants that more closely reflect Wisconsin generation sources. We continue to enhance the method for valuing emissions under Act 141. Under Act 141, we began to apportion the savings over each hour of the year, and we also began to base the data specific to plants estimated to be operating on the margin. So as you can see, there was quite a progression over the years from the beginning of the DOA pilot, which began in the 1990s, all the way through Act 141, which started in 2005. Key considerations in determining what method to use. As I mentioned, at first it was a fairly simple method, and it became more complex as the programs progressed. The key considerations were data availability, the cost of obtaining and developing the data, realism and accuracy in the estimation of the avoided costs, and we were also very interested in making sure the method we used was in alignment with the Greenhouse Gas Protocol Initiative, because this was broadly accepted and it thought to lend credibility to the results. Again, there has been a lot of change in the methods that we have used over the years. Our next speaker is David Sumi, who currently works with the program evaluator that the Commission has hired, who includes the estimation of greenhouse gases in our benefit cost analysis for energy efficiency and renewable resource programs. And as mentioned earlier, he was also involved in the early work for Focus on Energy in evaluating emissions for our programs. Information if you have questions in the future.
Over the presenter controls to you.
Should I use my version here?
Yes. Great.
Okay. Some of the early slides here, the pace will have to be brisk through these in total, but some of the early overview Carol has covered quite well. relating the background and goals of Wisconsin's energy efficiency programs and the evaluation to the state's objectives. So Focus on Energy is the portfolio of programs delivered pretty much statewide, and we calculate emission factors who provide estimates of the non-energy benefits coming from that are environmental in nature, but are based on the effects on generation serving the grid that in turn serves the customers who have the Focus on Energy programs available to them. The smaller bullet on that slide gives a summary through 2010 of the program attributable impacts in terms of emissions, quantified emissions, and a report is cited, and I should mention right now that you can go to focusonenergy.com, Focus on Energy, one word, and go to evaluation reports, and there are a number of different categories. Under the general category, you'll find reports over the past few years relating to the quantification of the emission benefit. We can move on from this. Recently, in the quadrennial planning process, there was input affirming that the use of carbon values to assess DSM savings through application of time-differentiated periods reflecting the carbon intensity of electric generating units operating at the margin at that time. And then, as you'll see in some slides coming pretty quickly, combining that with hourly energy savings projections. So we're operating here 87.60 each hour of the year. Timing dimension, a slide or two on this. Default emission rates can be adequate for some and perhaps many purposes, but it's become our view in Wisconsin that because we know that the program savings are not distributed equally across the year, and we also know from analysis of the emission data that emission rates fluctuate in important ways also over each day and year or hour of the year, that we needed to focus on the movement of these two relationships to try to do our best, our most credible best to capture an emission factor. And another key principle, identifying marginal generation, and we've spent a fair amount of effort over the past years doing that. And we got from Robin DeYoung a good definition of margin, what's at the margin, and it's pretty critical to getting an accurate estimation of emission rates. So that combined with, as I mentioned, the energy savings at different times of the day gives us the ability to estimate that hourly emission factor and apply it to the program energy impacts. So here are the data sources and guidelines that we use. As Carol mentioned, the greenhouse gas protocol gives some important guidance. We use EPA data, the hourly emissions data, labeled here as acid rain hourly emissions data, but I'm quite sure it's what Robin referred to as the Clean Air Markets Division database. So using the approach of combining hourly emission factors with hourly savings, we get a time of savings result, and we think this brings more information to bear and gives a more precise emission factor estimation. this is quickly a slide you may want to go back to at the Tech Forum site with some results for using different estimation approaches for the emission factors. And basically what happens if you use default emission factors using all generation on an average in Wisconsin, you end up overestimating the emission impacts because a lot of base load is included in those emission factors rather than focusing on the marginal load. Bringing this all into benefit cost analysis, as Carol mentioned, this is where in Wisconsin this particular non-energy benefit gets quantified, monetized. But with the method that we're used, we're able to provide hourly emission rates at the level of these 4 locational marginal price periods, which is an important dimension in the benefit cost analysis. And finally, the advantages, and this really echoes a slide that Carol showed as well, that using EPA data, we think a realistic estimate of the operating margin and hourly analysis, and for evaluators, a favorite quote from John Kenneth Galbraith. So that's it.
Thanks very much, David. A couple of questions for either you or Carol. One of them really goes back to all of the approaches that we've been talking about today, which mentions the fact that there are, their focus tends to be more on the short-term or annual emissions benefits from these types of programs, but as we all know, energy efficiency programs have very long-term benefits. So the participant is asking, how do you take into, how would it be different from what would you do differently if you want to capture more of the longer-term emissions benefits? And speakers take this one on first.
Right, I'll give one perspective on that. One of the other things we've done in Wisconsin over the past 8 to 10 years or so is to look at the trend in emission factors over time, and there have been some important changes, and basically it's attributable to the amount of gas-fired generation that is at the margin. And so emission factors have been getting somewhat lower accordingly. Now, to go forward in time and project is probably a reasonable objective. It's just that you will not be able to know the change in the emission factor pattern from the electric generating units serving your NERC region. We look at a combination of 2 NERC regions for Wisconsin. So with that caveat that you won't know how things are changing in the future, you might, and depending on the generation portfolio in your jurisdiction and how much change you might expect, that would be one caveat.
Do you want to add anything?
I was just going to add to that quickly. For the first time this year, the Commission determined that our energy efficiency and renewable resource goals will be life cycle goals. So we are beginning to look at things more long term, and it's likely that we'll take a look at, when we do benefit cost analysis, how we can bring that long term view of emission values into that analysis.
Thank you very much, Carol. Another question specific to Wisconsin was whether or not you have much cogeneration in your state, and if so, how do you handle that in these emissions quantifications?
Well, it would first of all depend, I guess, if it's grid connected or not. And I'm tempted to suggest that this might fall into the category of how to handle renewable energy, and the Focus on Energy programs have sponsored and delivered supported renewable energy program. And we, however, on the emission quantification, have not factored into current emission rate estimates renewable energy because we've been assuming it's not affecting the operating margin. And also, it's not under dispatch control.
Mm-hmm. This is a pretty specific question, and I know this is from one of our prior speakers, Colin High. So, David, on your slide number 12, you're talking about the time of savings approach, and Colin's question is whether or not his suggestion is that seems to underestimate the emissions rates as compared to an average emissions rate, which is usually the case considering that nuclear, hydro, et cetera, is in the base load. Can you talk briefly about the approach being used to when matching 8,760 hour savings against emissions?
Well, first of all, we do not bring into the emission factor estimation nuclear or hydro, and there is nuclear, not much hydro in Wisconsin or the Newark region serving here, but there is nuclear. So that's not there because it's non-emitting. And as I indicated in one of the slides, we do overall, as we look at trends in emission factors over time, and we look at using different emission factor estimation approaches and what results we get, we do believe that using an average emission factor that incorporates base load, which in Wisconsin would be primarily coal, tends to overestimate the emission effects of the programs, and that we're better looking at that margin as closely as we can, so that we get the actual the emissions for the units actually are likely to be on the margin, which is going to be a lower emission factor.
Thanks. I've had this question come up for a couple of our speakers, so let me open it up to all the speakers, and I'll let Wisconsin respond first. Have any of the states looked at the embedded emissions impact from different types of renewable technologies? For instance, they provide the example of PV panels, which might be manufactured in an area where they're actually using coal generation for their energy resource for that manufacturing. Have any of you looked at that type of emissions impact and taken that into account?
We have Matt in Wisconsin.
In Massachusetts, our greenhouse gas emissions inventory would take into account emissions associated with manufacturing anything in Massachusetts. So if the solar panels happen to be being made in Massachusetts, those emissions would be accounted for in our inventory. But that's kind of a different question than whether the power to make the emissions associated with making the windmill or the solar panel or the cement for the nuclear power plant are accounted for in this process, which in just the grid emission factors, they're definitely not in Massachusetts.
And this is Robin. The approaches I've laid out today do not take into account the embedded energy needed to produce renewable energy technologies, for example.
Thank you. Another question has come up during several presentations is whether or not there is a distinction or some qualifications that should be made if you're a state that is a deregulated state or a restructured state versus a state that still has kind of an integrated electricity system and regulation. So Specifically, I wondered if each of our state speakers could explain what your state represents in terms of a restructured state versus a regulated state, a traditional regulated state, and how that affects your calculations.
A traditionally regulated state. Again, because we have a statute that requires that the energy efficiency and renewable resource program takes into account environmental impact, that is the basis for how we determine how emissions are included.
In Massachusetts, we have a deregulated electricity sector, and you think about it from the DEP side of the house, the environmental side. I'm not sure that it matters one way or the other because your emissions are what they are. If you're choosing to incorporate imported power or exports of power, that doesn't seem to me that that's linked critically to whether you're a regulated or deregulated state. But on the PUC side of the house, in what one has to account for in benefits from energy efficiency, we have a court case here that says that the utilities are supposed to incorporate the costs of reasonably anticipated environmental compliance programs that are coming. So I think that probably is more a driver for what needs to be included in the thought process of deciding how much energy efficiency to invest in, more so than whether we were regulated or deregulated.
Mm-hmm. Thanks. Another question to both the state speakers. Do either of you account for line losses when you're looking at the emissions backed out from various sources of generation?
In Massachusetts, we do because the legislature required us to include that. So we look at wholesale level, not the retail meter level numbers, but rather the larger wholesale amount that needs to be supplied, which will shrink a little bit from line losses on its way to the customer.
I'm wrong, but in Wisconsin, we do include line losses when we determine the savings from energy efficiency programs, so they would be included in the analysis.
And this is Robin at EPA. We also recommend including line losses when you're doing your emissions quantification analysis for clean energy policies and programs.
I'm going to go back now to the question that came up about the NEEP approach, and the question is, is the EM&V that's developed by NEEP only for electric generating plants?
It's not for plants so much. It's for measures that one would implement, a light bulbs, fans, motors. So it's not about the generation of the power. It's more about the use of the power.
Okay, thanks for that clarification. One of our participants wants to know, having listened to all these various approaches, can you give our audience a rule of thumb about how much emissions are saved from a specific type of technology, say wind, in terms of how much fossil fuel generation is likely to be offset?
This is Sharon in Massachusetts. I'd say no.
Yeah. It seems like this whole presentation has been the best rule of thumb that you can get. You really do have to take the time to go through these various approaches.
And part of it is that each grid has its different types of power plants that supply that grid. So the benefits from a windmill in this example would be different in different parts of the country.
Another question for both the state speakers. Has Wisconsin or Massachusetts given consideration to an emissions performance standard for long-term generation resources in terms of, say, the amount of carbon per megawatt hour? It's a little bit off our direct topic, but if you'd like to respond.
My knowledge, it's not been considered in Wisconsin.
in Massachusetts, when we went through our deregulation, there was concern that maybe that act of deregulation would lead to greater emissions. So there actually was a thought put into doing an emission performance standard. But what happened when we had deregulation was that many new clean combined cycle power plants came into New England. And so actually our emissions have dropped due to deregulation, not increased. So that was the original concern about it. So it definitely has been thought about here.
Thanks, Sharon. And I'll take one more question that went specifically, David, to your presentation. And the question was, why are the marginal emissions so much larger than the time of savings emissions?
Our approach now is a time of savings, and it is based on this combination of hourly emission factor and hourly savings. So that is where we have the analysis. That's the level it's at right now, and we'll be over time re-estimating the hourly emission factors in part because, as I mentioned, the plants at the margin do change, and we'll be trying to bring even better data for hourly savings as the programs evolve. Note that answered the question.
Well, I think we'll take that as an answer, and we are at the bottom of our hour here, so we wanted to just remind you that there were a lot of questions, some of them very, very specific, so I didn't take those first, and we ran out of time here, but you have the contact information on their slides. You also have the contact information that the speakers shared with you that we've posted to the website, the EPA Tech Forum website. So if you'd like to follow up with them individually, they've agreed to do that. With that, I'll turn it back to Julia and Robin. I know we have some polling questions to alert our speakers or our audience to.
Yeah, thanks, Catherine. This is Julia. So we do have a few poll questions for those of you who have stuck around to the end. So if, Eileen, if you could put those up, I'd appreciate it. And then you all will have, I think, about a minute to complete these questions. And there should only be, I think, 3 or 4 questions. So I want to thank the speakers again. I really appreciated them spending their time with us and sharing their expertise. And as I mentioned early on the call, we will be sending out information on the next Tech Forum webinar, which will be held late in February on EPA's new greenhouse gas data tool. And we will send out the registration information in the coming weeks. So thank you all very much for joining us.
And do fill out the poll. Are there a couple of questions here? And we'll leave the poll open after we shut this down. But thanks very much for joining us today.